proportionality theorems. So I can use theorems and postulates and their converses or definitions to prove theorems about triangles. So a line parallel to one side of a triangle divides the other two sides proportionally. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. And the segment joining midpoints of two sides of a triangle is parallel to the third side and half the length. We will talk about each one of these individually today. Don't worry. All right. So let's get started there. Okay, the first one is the triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it divides the two sides proportionally. So prior to this one, when you saw parallel lines, all I had you guys do is draw the two separate triangles, right? But what this is saying is if you know that these two sides are parallel, and it hits on the other two sides of the triangle, then you can create a proportion with this piece and this piece, and this piece and this piece. So what this is saying is that if you know the lines are parallel, instead of having to know this whole entire length, so what I used to have you guys do, so versus saying RQ over RT equals RU, not RU, RS over RU. So here's what is happening here. Prior to this theorem, I had you guys add up this length and put it over the smaller triangle's length, right? Then I had you find this total length, you had to add those together, and put it over the smaller triangle's length, and then you would cross multiply to solve, right? That was the proportion you set up. But you don't need to do that anymore, but this only works if lines are parallel, so make sure you're careful here. So if lines are parallel, then you can say RT over TQ is equal to RU over US. You don't need the total length anymore. So look at that and see what questions you have so far. Okay, so if it says find the length of YZ, which I'm going to call X here, instead of saying this length is X plus 30 and this length is 79 here, we don't need to do that. We can say, because these lines are parallel, because WI and VZ are parallel, 44 over 35 is equal to what? What is 44 over 35 equal to? What would that be equal to? Which one corresponds with the 44? 30 over X. So these two sides correspond to these two sides. So you can cross multiply. What's 105 divided by... Oh, is that even right? Is that 1,050? I think I lost the zero at the end. Do 30 times 35. Is it 1,050?
Yeah.
Okay, so do 1,050 divided by 44.
What?
Divide that by 44. 1,050 divided by 44.
That?
I'm going to change that to a fraction then. So second. So that's 525 over 22. I don't want you guys rounding at all. So I guess that 2 goes into both of these. So since it doesn't give you a decimal that is not roundable, we can divide both top and bottom by 2. Okay, Rob, you're not sitting there if this is happening, okay? So we have 525 over 22. We don't want to round. If you have a decimal like 0.5, completely fine. You're not rounding that. But when you have decimals that aren't, you have to round, then you need to write it as a fraction for sure. All right, questions there? I feel like all these note packets have been giants lately.
And then our homework, is the homework over here?
No.
Okay,
I'll have to look at stuff with you to help you with that. Converse of the triangle proportionality theorem. If a line divides 2 sides of a triangle proportionally, then it is parallel to the third side. So what this is saying is that if these 2 segments are proportional to these 2 segments, then you know that these lines are parallel. So we're going to determine whether PS is parallel to something that's not here. I think that's supposed to be a Q. Is that what it looks like? Right, because it says QR and there's no Q anywhere on here, so I'm assuming that that's supposed to be QR. All right, so how can we determine if they're parallel? What would we do according to the converse of the triangle proportionality theorem? What would you do to check that? What does it say to do? It says if the lines divide the 2 sides of a triangle proportionally. So these 2 parts and these 2 parts are proportional. So what are my 2 parts here? Yeah, Ian.
I have a question.
Yeah.
There's T on it, but would T be in instead of I?
For this?
Yeah.
This is different than this one.
Oh.
This is an example. So if it was that one, yeah, that would be an issue. So, but it's similar to that, right? We're taking RT over TQ. So what is RT for us over here? What could RT be? What? PN. So it would be 90 over what? 90 over 50, because RT and TQ are in the same line. So it's 90 over 50 equals what? Somebody besides Ian. Come on, guys. You have your homework on this. Jill.
72 over 40.
Yeah, and then we simplify it. So I know 10 goes into both of these, so that's 9 over 5. 8 goes into both of those, so I divided top and bottom by 10. 8 goes into both of these. So that's 9 divided by 5. Are they in proportion to each other? Yes, so PS is parallel to QR. I lost the parallel sign. It's just a line. Yes?
So you don't cross multiply unless you're trying to find one of like the sides.
So if you're just using the triangle proportionality theorem, that means if lines are parallel, then those pieces are in proportion with each other, and you're trying to find a side. Yes. If you're using the converse, which means the flip of it, then you're just proving that the lines are parallel, which means you need to make sure those sides are in proportion with each other, so all the sides are given to you. You're just checking the proportionality. It's almost like when we were doing like the triangle similarity, like theorems and postulates, and we had to try side, side, side. We weren't really finding a third side, right? We were just setting them all up in ratios and making sure they simplified. Does that make sense? Okay. All right, let's get some examples done. So determine whether WY is parallel to YZ. So this is the converse. So the converse means that we have to set up proportions to check if they are in the same ratio as each other. So what would that be then for us, Hunter? What would we set up to check if this line here is parallel to this line here? No, because we don't have numbers on that. Remember, it says if the sides or if the pieces are in ratio, if these 2 sides are proportional to each other, then these are parallel. So what are the 2 ratios you set up to create the proportion? 15 over 20 equals 27 over 36. So notice this one here, Logan, we're proving that the sides are parallel. We're not trying to find a side. So we're just checking to see if that ratio simplifies. So, Harmony, what goes into 15 and 20? Hayden, what goes into 27 and 36? Are those in proportion with each other? Yep, they are. The ratios are the same, so WY is parallel to YZ. Feels good. Maybe it's because your Santa hat is really warm on your head. No, is it really hot?
Like, you walk in and it feels like a sun. Like,
That room's always been bad. Even for her big work, they're one of the girls that used to teach there that I'm still friends with. Used to teach in there, and it's always been bad. One of the principals once asked her why she was wearing summer clothes in the winter, and she's like, "Have you been in my room?" It's like the summer in here.
it's really bad.
Yep. Find the length of XY. So, Logan, in this case, you see how we're finding a side length? So we know that the lines are parallel, so we're just using that triangle proportionality theorem, which says that if lines are parallel, then those pieces are in proportion with each other. So Olivia, what would the proportion be to set up so that you can find x? Yeah, equals x over 15. This is not the only way to set up the proportion. Somebody else might have done 15 over x equals 8 over 20. Completely fine. There are different ways to get it, and you'd still get the same answer. So somebody, can you do 300 divided by 8? And we don't have to worry about that as a fraction because that's not a rounded decimal. So that's fine to write 37.5. I guess I should name that W or XY since that's the length we were finding. I can hear the clicking though. Yeah.
Okay, so why on the last one did we just like divide and not like cross?
So that you could technically cross multiply to see if they're in proportion with each other, but that goes off of like Logan's question. When do you do that? So when you know all of the pieces and you're trying to prove parallel, you're just checking to see that they simplify to be the same thing to prove that they're parallel. When you find the side, yes, you need to cross multiply to find the side. So it has to do with either using the converse. So the converse is when you're just checking, okay, or using like the straight theorem, which is the triangle proportionality theorem that finds the sides. Okay, does that help you? Yeah. So we're finding UR here. So Kylie, what would your proportion be?
Obviously.
Just try.
Okay. 6 over 16.
Perfect, okay.
And then, would it be 3 over x?
Yeah, and you have to do it in that order. You can't say x over 3. So since Kylie started with this one being in the numerator, since 6 is in the same spot as 3 on the other side, that's why they're both in the numerator. Since 16 is in the same spot on this one, that's why these are both in the denominator. So does that help you? Oh, I can do this division finally. All right, so what questions do you guys have so far about the converse and the triangle proportionality theorem? So we've had the same question twice, and it's a good question. Do you guys understand when we're just simplifying the ratios to check if they're in proportion and when you're supposed to actually cross multiply to solve? Do we understand that? Because that question's been asked twice, and I'm fine with that. Is everybody good with those two situations?
Can you go over it one more time to make sure?
Yeah, that's fine. So if you're proving lines are parallel, that's the converse. The converse asks you just to check. So it says, if the sides are in proportion with each other, then these lines are parallel. So that's why we're checking, if we're proving parallel lines, we're checking if they simplify to be the same thing, because that's checking if they're in proportion with each other. If you're finding a side length, that's just the triangle proportionality theorem, which says that you know these lines are parallel, now go find a side. So that's when you're going to cross multiply. Okay?
Yeah.
Okay, the corollary of the triangle proportionality theorem says, uses 3 or more parallel lines, left side equals right side as a proportion. Here's what this means. UW, WY equals, wait a minute, UW over WY equals VX over XZ. So it's not actually forming an actual triangle. It's just saying that you have 3 parallel lines, so it cuts it in 3 parallel lines. So those pieces correspond to each other. They're both in the numerator. And these pieces correspond to each other. They're both in the denominator. So if you have 3 parallel lines or more, you could set up more proportions if you had more. Those ones that are in between the outside two, so you see how we have an outside two and a middle parallel lines? So the ones that are created that are inside the outside parallel lines, you have segment, segment, and another segment here. So this cuts it. So let's see if we can figure this out on our own then. So it says solve for x. Devin, what proportion would you set up based on this?
FD over DV equals GE over DC.
So give me the... So what he said here is FD and GE align. That's good. And DB over EC. So you'll notice that he has those pieces aligning like it says above. Do you guys see that? So if we substitute in, FD is X and BD is 30. GE is X minus 4 and EC is 20. Whenever we have an expression in our proportion that is separated by addition or subtraction, it's a binomial there, and we need to put the parentheses around it so that we remember to actually distribute. Does it say it just says solve for x? So it doesn't tell us to substitute that back in and find those things. Okay, questions on that one? As we get into harder ones below.
Is it negative 12?
It's positive 12 because it's negative 10, or negative 120 divided by negative 10. It's way off there this time. I think my projector might be over there this time. Okay, so another example. In the diagram, angle ADE, BEF, CFG are congruent. So this and this are congruent, and this is congruent. So it says, are all congruent. This tells you 30, 12, 35, and we're trying to find DF. Okay, you may not set up those proportions unless you have parallel lines. So we have to go back a couple units. Remember when we learned about corresponding angles, we said if lines are parallel, corresponding angles are congruent? Remember that? There was the converse of that that said, the converse of the corresponding angles, it says that if corresponding angles are congruent, lines are parallel. So do you guys see that these are corresponding angles? So what lines are parallel here? Tell me what lines are my parallel lines. AD, BE, and CF, because those are corresponding angles. So now we know our corresponding angles create these parallel lines. Therefore, we can create our proportion. So not until you know that, Gabe, can you set up your proportions. So Greg, now that we know AD is parallel to BE, which is parallel to CF, because if corresponding angles are congruent, then those lines are parallel, what would the proportions be that I set up here? And try your best. We can always fix this, okay?
Okay.
This is difficult.
Would it be AB over BC
Okay, we can do AB over BC.
equals DE over EF?
Mm-hmm. So AB and DE are between the same two parallel lines. So those two are both in the numerator. And BC and EF are between the same two parallel lines. And that's why those two are in the denominator together. So we know AB is 30. BC is 12. DE is 35, and we are trying to find DF. Can somebody do 35 times 12 for me? 420? Is it 14? Can somebody check me and see if they got 14? Yeah, okay. All right, so we're trying to find Vx here. It's hard to see some of these things here, but it's called C. So we already know that these three are our parallel lines here. So these three are our parallel lines, so I'm highlighting those so that we really see that. So Abby, what is the proportion? And you can just give me the numbers if you want to. 9 over C equals 27 over 21. So 9 and C are in the same spot, so that's why those are together. And again, there's different ways to write these, so that's why it's good that all of you guys are answering them a little bit different, because this works too. And then 27 and 21 are in the same positions. But what's really important here is 9 and 27 are along the same line, and C and 21 are along the same line, so that's why those ones are together. So we cross multiply. Somebody's going to have to do 189 divided by 27. Huh? 7? Okay. So, what questions do we have on that corollary? What questions do we have on that corollary? We're getting there very slowly.
I have bunk bed, so you drop like, I'm on the top bunk, you drop all the way down to the bottom bunk underneath the bed, so I said, no, I'll get it tomorrow.
Makes sense. Why are you in the top if your sisters aren't home? Are they home now? Do you have like your own rooms at home?
Yeah, no, our own room.
Oh, I didn't know that. Okay. I was going to say, if you had to share a room with your sisters, like, I would understand when they're gone, I would totally be moving down to the bottom bunk.
Oh, no, I do not like, that's where I lay all my clothes for the week, where I plan all my outfits.
Oh, okay. All right, so the triangle midpoint theorem. A midsegment connects 2 points in a triangle. So a midsegment has two properties. It is parallel to the bottom, and it is half the length of the bottom. So here's what this is saying. It doesn't look this way, but this is the midpoint of RT. And this is the midpoint of TY. So if you know that's the midpoint, you know that these two are congruent to each other, and these two pieces are congruent to each other separately. We also know that the mid-segment is parallel to the base. And if we call this length x, this length here is half x. So if the base is 10, then that means Sx is 5. All right, so a walking path BD in a park intersects the sides of the park at their midpoints. So that means if this is the midpoint of this, B is the midpoint of AC, so I'm just marking as I go so I know what things mean. You walk from park corner A to walking path BD over the path to the other side of the park. So you have a little dude. Starts here. He walks this way. I never said I was an artist. And then he walks over here to the other side of the park up to the corner E. So he's walking this way. And then back down to his starting point. How many yards do you walk? So first things first. We have to use all of the things we know. We know that this piece and this piece are congruent because B is the midpoint of AC, right? So what is the length of AB? 90, good. So we have 90 here. We know that this is 68 already. What would the length of DE be if D is the midpoint of CE and CE is 216, Logan? How did you get that?
I just divided 216.
Yeah, that's the whole length that needs to be split into two pieces, so that's 108 yards. So then we need one more length here. How could we find EA? Helena? Right, we know that these two pieces have a relationship with each other, right? The mid-segment and the base have a relationship with each other. The mid-segment is half the length of the base. So that means it's smaller, right? So to make it bigger, we have to multiply it by 2. So 2 times 68 is what? So then we can just add all that up. So that's 90 plus 68 plus 108 plus 136. Did anybody add that already? What'd you get? Did you get the same thing, Helena? Okay. So that is 402 yards. The 68 is labeled here. I wrote over it and it looks really, and you guys, is it even, can you see it on yours really?
Yeah.
Huh? Can you see it? Oh yeah, it's right there. I just want to make sure you guys can actually see it. It's almost harder to see on mine because of the green, I feel like. All right, find FE. There is a lot going on this one. So, we have to look at this. FE is parallel to the base, right? Do you guys see that? So that's one of the pieces. The other piece is that E and F, it needs to be a mid-segment. So is EF a mid-segment? Is it connecting midpoints? Is EF connecting midpoints? Yeah, because E is the midpoint of AC and F is the midpoint of AB. So EF is a midsegment. Therefore, it is half. EF is half the length of BC. So if it's half the length of BC, then what is EF? What's BC's length? What's BC's length? 18, so half of 18 is 9. So since we have those pieces, we can do so. Okay, so we're solving for x in this one. We know that this is a midsegment because it's connecting the midpoint of both sides of our triangle. So we know that 2x minus 8 is what in relation to 2x plus 8? Half of it. So we're going to do half of 2x minus 8 equals 2x plus 8. So that's x minus 4 equals 2x plus 8. One minute. I did that wrong. Did I? 1 second. I did do that wrong. Sorry, guys. Back it up. Where should the 1/2 actually be? What? Sorry, I was overthinking the problem here. All right. So we have 2x minus 8 and 2x plus 8. Which one is, how would we make this congruent? It would be half of the base, right? So I should have put the 1/2 here. Or, what's another way you could have done this? Now that I'm looking at this too. Couldn't we have doubled this one? Or you could do 2 times 2x minus 8 equals 2x plus 8. I am so sorry about that, guys. So either or works. You either can double the midsegment, or you can take half of the base. You should get the same thing either way. So that would be x equals 12. And x equals 12. So whatever way you like better, you can do. Just don't make the mistake I just made. And yell at me if you noticed it. What did you do first?
Subtracted. Oh.
Are you okay? Okay. All right, last one. So in triangle MNO, X, Y, and Z are all midpoints of the sides. So that means that this is congruent to this is congruent to this, and those are congruent. We'll get through as many of these as we can, and then I'll get your homework out. So this is doing 4 different problems in one triangle. Do you guys see that? So some people like to draw the triangle 4 separate times to see it, or you guys might just erase. Just don't confuse it as the same problem. Does that make sense? So XY is X minus 2, and MZ is 3X minus 7. Says find the length of MO. So if this is 3X minus 7, then this is, what is this? 3X minus 7. So this is the mid segment of this. So we can do 3X minus 7 plus 3X minus 7 is equal to twice the length of XZ, because remember, it tells you that this is half of this, right? So I can double it. So that's 6X minus 14. Why did I put a Z there? That's a 2. Right? X minus 2. So that is 2X minus 4. So X equals 5 over 2, or 2.5. Okay, next one. YZ is 3X plus 1. And MN, oh, we didn't even find the whole length. So MO would be, you have to plug it in. So I'm just going to do this one with you, and then I'm going to get your homework out. We'll have to go over questions tomorrow. So MO is 6X minus 14. If I plug in 6 times 2.5 minus 14, I think it's 15 minus 14, is MO, can somebody do 6 times 2.5? Okay, MO is 1 apparently, somehow. It's a really tiny triangle. All right, so let me get you guys your